So here's the data path. You can use that to reference in the next instruct questions. So, which of the following statements are true? All right, so the answer is the only one of these that's true is that mem to reg, and mem to reg is over here. It's the mux that selects what comes out of the what we take and put into the register file. Do we take the read data from the memory or the value from the ALU? This always selects the ALU for R-type instructions. Now that's true. If we're doing an R-type, we're going to take the result of the ALU and we're going to write it in. But what about the other ones? Well, if you look at this here, reg write is not true for an I-type instruction store word. So if we're going to store data into the memory here, we're not going to set reg write to true. We're not going to write into the register file when we're storing a word because we don't store data in the register file, we store it into the memory instead. PC source doesn't always select ALU result for I-type instruction. PC source selects PC plus 4 for non-branch instructions, or it will select PC plus 4 for branch instructions that aren't taken. Let's take a look at data path control. So if I want to do the instruction BNE, what are the control signals in the data path? Well, we can take a look at this. So branch not equal, it's not going to write to the register. There's no result to write back, so all of these are write equals 0. BNE is going to compare two registers. So we need to read out two registers. So we're not going to take the sign extended results because we need to get two registers out. That's saying that over here when we go into the ALU, we need to take two register values because branch not equal compares two registers. The ALU operation is going to be subtract to compare them. And now the question is, what do we use for the PC source? What do we use over here to decide whether or not we jump? Well, it's branch not equal. So we want to jump when 0 is not true. Now, let's take a look at branch control. So remember we had originally in our data path a single branch output from the control logic, but that wasn't enough to handle both branch not equal and branch equal instructions. Why was this? Well, it turns out we need to be able to interpret the ALU's output different for each one of those. So if we have a 0 output being true, that means the values are the same. That means we do take a branch for a branch equal instruction, but not for a branch not equal. We need to know for branch equal or branch not equal if we should interpret 0 or not 0 as the indication to jump.